Hello, welcome to Spiral 3 and Lesson 3. And today what we're doing is we're just looking at the volume of prisms and cylinders. So we've got our 3D shapes. We're just interested in volume, and I want to make sure you know how to calculate them. So the first thing we're going to look at here in the note is, do you know the difference between pyramid and a prism? So in the diagram below, I have a whole bunch, and I'm going to use different colors here to identify them. You can put letters on top if you don't have different colors. So let's start with, I'm going to start with cones. Cones are the ones that I think we're all should be comfortable with. Cones have circular bases. So if I look for my cones, I see that 16 is a cone, and I think that's the only one. All right, so over here in cones, I'm going to put, they have circular bases. So if we have a round base, we are dealing with a cone. Next, I'm going to move into cylinders. So cylinders in blue. A cylinder is like a silo or a tube, so that has a round base at either end. I believe that's got all of them. So a cylinder has a circular base at each end. All right, now we're into the trickier ones. Now, we have prisms and pyramids, okay? So let's go with prisms, all right? So I'm gonna get my green out. So prisms. Prisms are 3D shapes, all right, that are uniform, okay? So for example, this shape right here, okay, is what we would consider a uniform shape, okay? Number 6, that's a prism. This is a prism because they have kind of a uniform shape. 7 and 8 are prisms. And then here are the outliers. Number 3 and 22, these are also prisms as well. That's because we can hack off the triangular part and we can put it over here, which would essentially create one of our prisms. So those guys, all right. Now, if we're to match up or whatever's left, all right. Oh, actually, I apologize. I've missed a cylinder. This guy's a cylinder as well. All right. Kind of a funny cylinder, and one we're not going to have to worry about in the grade 9 course. Let's look at the red for a second then. So pyramids. What do pyramids have in common? So if we look at all of the pyramids here, what do they have in common? They have some kind of base, and they all meet at a point. Okay, so a pyramid has a type of base and meet at a point. All right, so they have a point where all the sides come to. And then for the prism, okay, it's one of our 2D shapes, squares, okay, or trapezoid, 2D shapes that have been stretched into 3D. All right, so we stretch the shape, so square, now we stretch it, and now it's a square all the way up, or a rectangle all the way up. All right, so let's take a look at how we calculate our volume. So the basic formula is that it's the area of the base of an object multiplied by its height. All right, so let's talk about that. If I take a square, let's see how I can draw this. All right, so here's my square. So from the square, okay, and this is going to be square in 3 space, we have a length times width. All right, so that gives us our base. So area of our base, in this case, is length times width. Well, what happens in a 3D shape? So you can see my artistic skills are not too bad. But what happens is, all we've done is we've just put a whole bunch of, think of it as a deck of cards. a whole bunch of a whole bunch of cards have been stacked up to give us some depth here. So we take the area of one card, multiply it by the depth to give us the volume. So we're just taking the area of a card and then multiplying by how many cards are there. And this is true, it works for every shape. So even if you had a funny shape like this, I did it in 3D, all it is a whole bunch of those areas there. So if the area was 10, then all those slices, if I told you I put 50 slices on, the area or the volume would be your area multiplied by how many you put in there. So just be 50 times 10. That's the premise of volume. Volume is just a whole bunch of areas stacked on top of each other. So into some examples for you to work with. So you will want your formula sheet. You want your formula sheet for the grade 9 EQAO. That's the one that you're going to get on tests. So you want to practice with it. So find the volume of a rectangular prism. If you find the shape on your formula sheet, it's going to be length times width times height. It does not matter what is your length, width, and height. So if I say that this is my width, 8 then would be my length, 4 is my height, it does not matter. We're multiplying, so the order in which we put them in will not matter. All right, so 5 times 8, that's 40. So we end up with 160 cubic inches. All right, so this should be reviewed. You should have seen this in your grade 8 year. So make sure you can find it on the formula sheet so you're comfortable with it. Next example, we have a triangular prism. Triangular prism. So on the formula sheet, I believe it's base times height. Oops, they have it separated, sorry. They've separated it, and we have area of the base, and then the volume is the base times height. So let's just treat this as a triangle. So base times height over 2. So we want to find the area of the base. So we are finding the area of that base. So our base is, I'll do it in red, this length here, which would be my 12. Now my height. The height is the height of the triangle. So that's the 6.3. We're going to divide that by 2. So we find that the area of that triangular base, 12 times 6.3 divided by 2, is 37.8 square feet. Okay? Now, how many squares or how many triangles have we stacked on top? So basically, I'm going to erase this so I can see it again. So basically, we've taken that shape and we've stacked, think of it as 7 of them on top of each other, 7 areas. So my volume formula would equal area of my base, so that's the 37.8, multiplied by, I stacked 7 of them on top of each other, so it'd just be 37.8 times 7, which gives us a volume of 264.6 cubic feet. So that's all that formula is really doing. So some of you may be comfortable with the final form. Volume equals base times height times depth or length over 2. All right. So you can do it in steps. Step 1, find the area of the base. Step 2, multiply by its depth. Or you can go and use the final formula. All right, on to example 3. So now we have a cylinder, so we're just going through. Again, locate the cylinder on the formula sheet, please, because you want to use your formula sheet and get used to that. We've broken it apart into area of base and then volume. So area of base, so here we go, we have a circle. The diameter is 10. So you got to be careful with this. That means the radius is 5. So what is the area of a circle? Well, it's pi r squared. So that's going to be 3.14, that's my pi, times 5 squared. So I'm finding the area of the base of this cylinder. So 3.14 times 5 squared. So the area of the base is 78.5 centimeters squared. Now, we have stacked 10 of them on top of each other. So we have 10 circles 10 areas that have been stacked on top of each other. So that means that the volume is area of your base, 78.5. And we've stacked, we said 10 of them on there. So our final volume is 785 cubic centimeters. Excuse me. All right. So you can do it in stages. So again, we have stage 1, find the area of the base of the shape. Stage 2, find the volume. Or some of you look at the formula and you see volume equals pi r squared h. So if you feel comfortable, you can just go ahead and use that single formula rather than doing it in steps. But you need to be comfortable and be able to use your calculator properly. Example 4. So this is a trapezoidal prism. Okay, so in the first unit, when we did 1D, or the first spiral, first thing we did, we found the area of the base. So we're just going to find the area of this trapezoid. So I'm doing it in stages, stage 1 and stage 2. All right, so stage 1 here, we're finding the area of the face of this trapezoid. So you'll be more familiar with a plus b in brackets times height over 2 rather than the 1/2. So a plus b, so that's short side plus long side. So it looks like it's going to be 2, and my long side over here is 6. So 2 plus 6. My height is in red here. That's the 3.5 divided by 2. So this is going to give me the area of that face. Please be careful with the calculator here. You need to do that addition first. So 2 plus 6 is 8. Then we multiply by 3.5. Then we divide by 2. We find we have a face area of 45 inches squared. All right. Now we have a whole bunch. It's like a deck of cards. How many of them do we have? A little blurry on mine here, but it's 6. So the volume is area of my base, which was 14, and there are 6 of them. So we end up with 14 times 6. So that's a volume of 84 cubic inches. All right. Now again, you may be using comfortable going straight to the final formula, which would be a plus b in brackets times height times length. That would be the depth over 2. But I always recommend doing it in stages. It's a little bit safer when you have multiple calculations like that. All right. And our final example then, number 5, a can of jelly beans, Jelly Belly jelly beans, has a diameter of 4 centimeters and a height of 7. So sketching this out so we can visualize it. So there's our can. It tells us that there is a diameter of 4. So that's 4 centimeters, a height of 7 centimeters. A box of Jelly Belly jelly beans has a base that is 10 by 5 and a height of 7. Which holds more? So we're looking at comparing the can with the box. So if I draw a box, see how my box goes here. Not too bad. So this box is 10 by 5 by 7. So we're just comparing the two volumes here. So I'm just going to work underneath. So the volume of the cylinder, so volume equals pi r squared h. So let's try the formula using it all in one. So 3.14. Now be careful here. It says radius. All right. So our radius is 2. So it'll be 2 squared, and the height is 7. All right. So what's our prediction here? What's our prediction? You think, which one do you think is going to be bigger when you look at them? So think of it this way. What would the cylinder be able to do if we had the box that has similar dimensions, 10 by 5, and this one? We can see that the diameter of this can is 4. It's going to fit inside this box without any issues. So I'm going to bet that the prism, the box, is going to have more room. So that's 87.9. And I'm going to have to tie this up in the next video. So we'll see you in a sec.